Hi, I'm Ellie, and I just finished my final year studying computing at Imperial. For my final year individual project, I created Diligent to give continuous formative feedback to programmers. Most online programming courses and program analysis tools give very correctness-based feedback, such as compilation errors or the outcome of unit tests. The aim of my project was to go beyond this, to encourage programmers to solve a problem well, rather than just solve a problem. So let's look at Diligent in action. Here we've got IntelliJ open, and the core part of our solution is an IntelliJ plugin, which as you can see is installed. If we create a new Java class, and let's call it example, and our task is to write a function which, given a number, returns true if and only if that number is even. So let's go ahead and write that function. And as you can see, a notification has appeared in the bottom right-hand corner saying Diligent, updated feedback report, click here to view. And this is the feedback report, which can be viewed in the browser. Example appears on the left-hand side, and we can see our feedback message saying, have you used camel case throughout class example? This gives us a nudge in the right direction, and we can return to our code to see that the method name needs to be in camel case. So if we change this, another notification appears, we return to the feedback report, and we can see this positive message telling us we've managed to fix it. However, we still have one of the issues. So if we return, we can see this is coming from the parameter name. And so if we refactor this, another message appears, we return to the feedback report, and we can see we've now fixed all of the errors. You can also see the notion of priority in the messages here. So if we fixed 2 high priority, we had no medium, and we had no low priority errors. So here we not only have a functional piece of code, but we've improved our coding practices and we've learned more about how to use camel case. Diligent can detect on a wide variety of issues, as shown here. So the first is camel case, as we saw in the demo, but we've also got things such as method length, or looking for strings being compared with equals equals instead of using the object method. However, you may want to only look for a selection of these issues. To do this, you can configure the Diligent plugin with a configuration file. To make creating configurations as easy as possible for users, I built a website where they can use a drag and drop system to create their desired configurations. Using the website, the users can also view, edit, and delete configurations and download the corresponding configuration file. The most technically challenging part of my project was implementing clone detection. Code duplication leads to code which is hard to maintain, and it is also a symptom of poorly structured code. To encourage users to minimize their code duplication, Diligent uses a clone detection algorithm to identify identical or similar blocks of code, and it then notifies the user. Diligent was run on several student submissions, and its detections were then compared to a human tutor's comments. It performed really well. It achieved a perfect recall score of 1, a precision score of 0.995, and an F1 score of 0.997. Overall, it outperformed the human tutor. During this project, I also developed Diligent for Python to demonstrate that the overall approach which my automated analysis takes can be applied to any programming language. The success of this project can be summed up with a quote from user testing. Using Diligent felt like a tutorial when someone writes code on the board and the tutor nudges them in the right direction. Thank you for watching this video.